is made up of two cavities, an anterior cavity and a posterior cavity, or a vitreal chamber. The anterior cavity is made up of two chambers, an anterior chamber and a posterior chamber. Within the anterior chamber, it is everything from the cornea to the iris. The posterior chamber within the anterior cavity is everything from the iris to the lens, which sits behind here. Within the anterior cavity, the fluid is called aqueous humor. Within the posterior cavity, which is everything from the lens to the back of the eye, the fluid inside is called vitreous humor. So there's three tunics within the eye. The first is the fibrous tunic, the second is the vascular tunic, and the third is the nervous tunic. The fibrous tunic consists of two layers, the cornea and the sclera. The vascular tunic consists of three, I think. So you have the iris, the ciliary body, and the coracoid. So it's three layers: iris, ciliary body, and the coracoid. Choroid, sorry. And the choroid here on the back of the eye. And then the nervous tunic is composed of only one layer, the retina, which is almost all gone, but it's this tissue right here that covers 3/4 of or 2/3 of the eyeball in the back. So the lens is this piece right here, sits behind the iris, and is connected to the ciliary body by suspensory ligaments.
Which is not shown?
Not shown because we ripped them out when we pulled the lens out. I don't know that you could have seen them anyway. So on the eye, let me look here real quick. This area right here where the retina is bunched up, you could see it, you used to be able to see it real good, is the optic disc. It's also known as the blind spot. It runs through the back of the eye to the optic nerve. Somewhere in here,
how does it look like again?
Optic disc is right there. See, it's kind of a roughened area. But if the tissue's intact, it looks like somebody took a piece of metal and stuck it in there and wrinkled it up, and it looks like, and you can actually see the outline of the disc, but it looks all wrinkled around the hole. The maculata, and I don't see it on here anymore, and it could be because of tissue, right? But the maculata is the exact center of the eyeball looking through the cornea. So if you took a pen and ran it through where it's stuck, exactly in the center of the cornea, where it's stuck in the back of the eye, it's a maculata. Within the maculata is an indention in the back of the eye. That is the fovea centralis, and that is where a concentration of cones exists. And that allows you to see color and resolution, sharpness. So on cones, that's the only location of cones. The other type of thing is rods, and they're located along the borders of the eye, or the fattest section of the eye. So it's kind of like, the equator of the eye, if you want to say, along the sides, and they allow you to see contrast. In other words, dim light, see at night, basically. Black-white, if you want to. They used to say black-white. Now I guess they don't say that anymore, so it's seeing darkness.
Brad, what's the blue?
This is still part of the
retina?
No, the choroid. It's just, but that's it. The retina is this tissue. See how it was all spread out, and it actually came up to here.
Ask about the macula lutea.
What's the exact center of the eye? In the back of the eye, what is the exact?
I would say fovea centralis.
Well, that would be somewhat true, but according to the book, what I read was the fovea centralis is